So first copy that what was given. Write down solution. P of A equal to 6 out of 11. 6 out of 11. P of B is 5 by 11. P of A union B 7 out of 11. And the first thing, P of A intersection B equal to P of A intersection B equal to. So if you from addition rule you can calculate this part. Okay. So from addition rule, P of A intersection B is defined as P of A plus P of B minus P of A union. Okay, this is also called addition rule. And you learned that already, that P of A union B is equal to P of A plus P of B minus P of A intersection B. This is also addition rule by just changing the terms. Okay? By doing zigzag, you get this. What is P of A? 6 out of 11. P of B is 5 out of 11 minus A union B is how much? Look at here, 7 out of 11. Okay. So 7 out of 11. So overall the denominator is 11. So 6 plus 5 is 11. 11 minus 7, 4. 4 out of 11 is the correct answer. So the first question completed. Next we will do second question. The second question is P of A by B. P of A by B is P of A intersection B divided by P of B. Okay. P of A intersection B by P of B. So what is P of A intersection B? Just we got here. Yes. 4 out of 11 divided by P of B is 5 out of 11. 11 got cancelled. So 4 out of 5 is the answer of this question. Okay. And third question. What is third question? P of B by A. P of B by A. Similarly, you can define like this. P of A by B is P of A intersection B by P of B. As the same, you can define this one also, P of B by A. Look at this denominator. What is the denominator here? P of B. That should be written here, P of B. In the same way, here what is in the denominator? A. So that should be in the denominator, P of A. And numerator is always P of A intersection B. What these are called? A by B and B by A are called conditional events. What is the meaning of this A by B? B will happens first. After happening B, A will be happen. Okay, that is the event is called conditional event. It is denoted by P of A by B. And what is P of B by A? The same way you can define this. Yes, first A will be happen, and after that B will be happen. Okay, that is what called B by A. Okay, always the denominator should be happened at first. And next numerator, very next numerator. That kind of situations are dealt as conditional events. Okay, these probabilities, these are the formulas for calculating the probabilities. And we already done that P of A intersection B is 4 out of 11. And what is P of A? 6 out of 11. So 11 got cancelled. 4 out of 6. 4 out of 6 is how much? 2 by 3. Okay. Understood? Next question. 22. 22, copy this question. A and B throw a die alternately. A and B throwing the die alternately. One of them gets a number greater than 4 and wins the game. Greater than 4. Okay. Greater than 4 means they are playing with die. So die means you know. So what is die means? It has 6 faces. Okay. And 1, 2, 3, 4, 5, 6 are the numbers on that die. Okay. So there, how many players is there? A comma B. 2 players playing a game with die. So he said, okay, they together considered that more than 4, greater than 4. Not what happens exactly for, we don't know. Greater than 4, it is called wins the game. Okay, that is the condition there. If A starts the game, who starts the game? A. What is the probability of B winning? So he wants B winning probability. Okay, B winning probability is asking. Okay, I will tell you one scenario, one basic concept of this thing, and then we will do this question. Okay. So in the same way, for example, P is always denoted by winning. This is formula. P is always denoted by winning. Q is always denoted by failure or loss, whatever it is. Failed. P is winning, Q is failed. Okay. So two players are playing. A starts the game. So probability of A wins always. Probability of A wins always. This is concept. Write down this concept. A wins always. So first day, what are the chances of A winning? Either he can win in one time, or second time, or third time, or 4 times he can win, and so on. It was continuous. So first we will discuss first time winning. Who is rolling die at first? Mr. A. He rolled the die, he wins the game. Completed. Plus or means plus or. So we can't configure that the first toss he can win the game. We cannot say like that. So there are other choices also. So you know that at first time you can't win. You can't win at the first time. If you wins first time, that you are lucky fellow. If you, so you can try. If you not win the first time, you definitely will try for the second time. If you are not win the second time, definitely will try for the third time. And until getting a winning, you cannot leave that war. Yes or no? For example, if you are playing like video games or something, or online games you are playing, definitely at first time winning is impossible. So by winning and winning or getting fail, and you can learn something. The situation, the odds against of that work, everything you learn. Yes or no? So in the same way, the choice for or the probability or the chance for getting at first time winning is P. Now or there is another probability, another choice is also there. Definitely he will get in second chance. Second chance means first time he should fail. So Q. Again, or for your imagination or picturization, I am saying that first day he will win, and second day, second round he will win. Second day they came, they sit together, and they are playing. They're playing with the die, and A throws the A roll the die, and he lost. Loss means Q. So definitely, if he lost, the first player lost, the die will be transferred to the second player. Second player definitely lost. Why definitely? Because we are checking here for the first player winning. Okay, so Q. So both A failed, B failed. Now second round starts. So in the second round, A wins the game. That means at first, A wins the game in first round. In second choice, he wins at second round. Okay. And then they get shake hand and they went to their homes. And third day they will return and they are sit together again start playing with a die. And this day, because it's a third day, we are giving him his winning in third round. So first round, uh, both failed QQ. Second round, both failed QQ. Third round, Mr. A wins the game. And the same way, the process is continuous up to um, infinite number of times. So P plus, can you tell me what is it? It's a multiplication. It's a work now, so you should multiply it. PQ square plus PQ power 4 plus and so on infinity. So this is equal to P is a common term. So 1 plus Q square plus Q power 4 plus and so on infinity. Okay. P of, what is this? This is a GP, geometric progression of infinite number of terms. So this is what called S infinity, A by 1 minus R. What is A? First number. Common ratio is Q square. Okay. So this is the formula you should use for winning Mr. A probability. Winning of A probability is P by 1 minus Q square. Remember this formula for P of A winning. Okay, understood this process. I'm just explaining this process to remember this formula only. Two players are playing. The first person will win. The probability is P by 1 minus Q square. What is P here? Winning probability. What is Q? Failure probability. How many players are playing? Two players. So that's why Q square. That's why Q square. If three players are playing, then it will be Q cube. Q cube. Okay? Understood? So now, what about Mr. B? So B is winning. Now again we will calculate B is winning. The same process. Always Mr. A could be failed, and first round B will wins the game. Okay, this is the first day. A always fail because he starts the game. A starts the game. He will be failed because we are calculating B winning. So B will wins at first round. Next day, we are decided to giving the winning of B second round. So QQ both failed. Second round started. A will be failed and B will be getting winning. So and so on the process continues. If you calculate this, you will get PQ by 1 minus Q square. This is the probability of B winning. Just apply the PQ as a common term. Okay. 1 minus 1 plus Q square and so on. It is infinite GP. So A by 1 minus R, 1 by 1 minus Q square. Suppose if three players are playing the game, let us suppose those three players are Mr. A and Mr. B, Mr. C. A starts the game, then B next and C next. So the first person winning probability is, look at, understand these formulas. P by 1 minus Q cube. Q cube, understood? What is B probability? What is B probability? PQ by 1 minus Q cube. Always denominator 1 minus Q cube. Three players are playing, so Q cube. And what is P of C winning probability? PQ square by 1 minus Q cube. Understood? Yes or no? So here you understood that it is Q power 0, it is Q power 1, it is Q power 2. First person Q power 0, second person Q power 1, third person. Always 1 unit decrease of the power of Q according to that person's number. Okay. So we can generalize this thing. Now we are generalizing. How many players are playing? N players are playing the game. Now, N players are playing. Can you tell me what is the probability of the first person will wins the game? P by 1 minus Q power N. What is the second person winning? PQ by 1 minus Q power N and so on. In this way, you can define everyone's probability in the game. Now, coming to the question. It's just a 3 marks question. You can take the answer. So first we will define P and Q together. What is P stands for? P stands for greater than 4, it is called winning. Greater than 4, it is called winning means the die will show 5 or the die will show 6, that is called winning. And the die shows completely 6 results 1, 2, 3, 4, 5, 6 results, 2 out of 6. 2 out of 6 is 1 by 3. Q value will be 1 minus P, that is equal to 1 minus 1 by 3, which is equal to 2 by 3. Now you understood that. Okay. Now who's winning he is asking? He is asking Mr. B's winning. So that means the second person winning we needed. Okay. So look at here. So this value, the formula is PQ by 1 minus Q square. PQ by 1 minus Q square. Okay. So what is P? 1 by 3. What is Q? 2 by 3 divided by 1 minus Q square means how much? How much? Q is 2 by 3 square. Now can you tell me how much is it? 2 out of 9 divided by, this is 4, this is 9. Tell me how much? 1 minus 4 by 9. 5 by 9. Am I right? So 9 got cancelled. So 2 out of 5 is the probability for this question. This is the answer. Okay, this is 3 marks question. Understood? All you need to know the concept first. Then you can do these questions. Next question. So look at, check the answer 2 by 5. Next, 23rd question. Copy this question. Find the probability distribution of the number of success in 2 tosses of a die where a success is defined as number greater than 4 and 6 appears on at least one die. Copy this question. This is also same concept. When die tossed, how many results will be appeared? 1, 2, 3, 4, 5, 6. So probability of success, that is a number greater than 4. Only 2 we are having, so 1 by 3. X denotes the number of success. Okay, second case. So X is equal to 0, 1, 2. So X is equal to 0. Then what is the number? 1 minus 1 by 3, this part. And 1 minus 1 by 3. This is 4 by 9. X is equal to number of successes. So how many we should calculate this part? Number greater than 4 is success. We have to define success in 2 tosses. 2 tosses of a die. 0 success, 1 success, and 2 successes. This is the distribution table. Okay. The probability of distribution, we should create a distribution. Distribution means all things happen that will be calculated. That will be created as a table. That means table we should calculate. Should create a table of success. Okay, write down X is equal to number of success. Number of successes in 2 tosses of a die. How many times they are doing this? 2 times they are doing. They are tossing 2 twice. What is the probability? The first question is P equal to number greater than 4. So P value is equal to, what is P value? Number greater than 4 means, just now we calculated that, 5 comma 6 out of 1, 2, 3, 4, 5, 6. So 2 out of 6. So probability P is equal to 1 out of 3. Automatically failure probability will be 2 by 3. Now we will calculate 2 tosses they are doing. No? So X is equal to 0. Number of success, one success, two success. These are the possibilities. Okay. So why only 0, 1, 2? Two tosses he is doing. Two tosses. What are the outcomes will be happen? No success. Okay. So both success. That means both die shows more than 4, or one die shows more than 4 and another die shows less than 4. Okay. These are the possibilities we will get. So probabilities are respectively for 0 success. X means success of the getting success or winning. So 0 winning. 0 winning means both failure. Both failure means first toss failed, second toss failed. That means how much is it? 4 out of 9. Just tell me one success. One success means either the first or second one. Only one success means 1 by 3 into 2 by 3. This will be 2 out of 9. Two success means 1 by 3 into 1 by 3 is equal to 1 out of 9. Okay. So this is the answer for the first question. What he asked for the second question? Second question, he said success probability defined as 6 appears on at least one die. 6 appears on at least one die means the probability will be having 6 on one die. Having 6 on one die means total 36 elements exist because two dice are rolling out. So 6 will be appeared how many times? How many times? 11 times. 11 times. 6 times 61, 62, 63, 64, 65, 66. What about 1 6? 1 6, 2 6, 3 6, 4 6, 5 6. Totally 6 plus 5, 11 times we are having. So 11 out of 36. 11 out of 36 is called success. Automatically 25 out of 36 will be failure. So what are the choices? X denotes the number of success. What are the choices? Either 0 or 1. Why 0? Because no die shows 6. That is the possibility. Or one die will show 6. That is the probability. Okay. So 0 and 1 are the only possible values. So create the table for 0 and 1 like this. Can you do this? Do it yourself. Had you copied this question? So second question, x is equal to, what he said, x is equal to 6 appears on at least one die is a success definition. X is equal to 6 appears at least one die. Six appears at least one die means it shows 6. It shows 6. These are two dice. It should be shows 6 and this will be 0 case. This will be 0 case and 1 case. That's what we are doing. Okay. At least one die will shows 6. So what is the other die should be calculated? It is not showing 6. It is also showing a 6. Understood? That's why we are doing X. So first calculate the probability P equal to, success probability P is equal to. So how many events we just calculated? I just said the 6 1, 6 2, 6 3, 6 4, 6 5, 6 6 and 1 6, 2 6, 3 6 4. The total 11 events out of 36. So therefore this implies Q is equal to 25 out of 36. Okay. Now X is equal to 0, 1. So probability will be 0 means what? 0 means how much? 0 means what? 0 means 25 out of 36. 1 means 11 out of 36. 0 means total failure because already one die shows. And look at the denominator. Both dice are considered. There is a layer, you should understand that. So not showing, the other die not showing 6, that is 25 out of 36. Okay. And this 1 is called, what is this one? Success probability 1 means 11 out of 36. Make a table like this. Then next question. An arm contains 5 red and 5 black balls. 5 red and 5 black balls. An arm contains 5 red and 5 black balls. A ball is drawn at random. A ball is drawn at random. Its color is noted and is returned to the urn. Moreover, two additional balls of the color drawn are put it in the urn, and then a ball is drawn at random. What is the probability that the second ball is red? Okay. So first, how many balls in the urn? 5 red and 5 black. Total, how many balls? 10 balls in the bag, in the urn. A ball is drawn at random. Its color is noted and is returned to the urn. That means you are selecting a ball and observing the color and return to the urn. And then what is you are doing again? Moreover means extra work. What you are doing extra work? Two additional balls of the color of the same color, or what color? Of the color drawn are put in the urn, and then a ball is drawn. Again, two more balls of the same color was again dropped in the urn, and again one ball is selected from the urn. So again you are substituting one, you are dropping two more balls from some place. From another place, you are getting two more balls and dropped into the urn. That means total balls will be increased by 2. That means before there are 10 balls. Now it is 12 balls. And then what you are doing? A ball is drawn at random. What is the probability? The second ball is red. The first ball you don't know. Two balls he is drawing from the urn. The second ball should be red always. So here before the first draw, we totally having 10 balls, 5 red and 5 black balls. And before second draw, we have a total 12 balls. Before second draw, we have a total of 12 balls, either 5 red balls, 7 black balls, or 7 red balls, and 5 black balls. Okay, this is the composition, new composition. Understood? You are drawing one first draw. You are drawing first draw. If it was red color ball, what you are doing? Two more red balls are added. The first draw is a red ball. Somewhere you are getting that more two more balls, two red balls, and drop into the arm. Okay, and as a second draw, you should draw the second ball, a red ball. If you are in the first attempt, you are drawing black ball. That means you are adding two more black balls somewhere else. And again, you have to draw red ball only. As always, in the second attempt, you should draw the red ball. In both cases, for the second draw, there are 12 balls available in the bag. Understood or not? Look at this arm. This is arm. How many blue balls? Black balls are 5, red balls are 5. Okay, a person taking black ball. Taking black ball. Okay, first draw. First draw black ball. So two more black balls are added. Two more black balls are added. And this will be also he replaced that. He replaced this ball. That means again 10 balls are ready for the second draw. Again, what he is doing, not only that, moreover, he is dropping two more balls, two more black balls. That means total 12 available for the second draw. And at the second draw, always you have to red ball. As a second draw, always he has to draw a red ball one. Understood? So write down. So let B1 is equal to first ball black. R1 is equal to first ball red. R2 is equal to second ball red. Okay, always second ball is red. Understood the process? If you understood the process, then only you can do this question. So what we are doing is, first we will calculate, first draw will produce a black ball. Black balls are how many? 5 out of 10. If you draw the first red ball, then P of R1 is also 5 out of 10. Okay. After drawing, first ball is black and the second ball will be red. What is the probability for this? First ball black and second ball. So total 12. Total 12 balls available in the R. So 12 in the denominator. Red balls are 5 only. So whose composition is increased? First drawn ball is black. So that's the composition is increased as a 7 for the second attempt. Okay. So red balls will be 5 only. So we will keep that 5 same. And what happens here? We have to draw second attempt. Always we have to produce red ball only second attempt. And the first attempt will be R1. So again 12 balls available in the back. 12 balls available in the back. And how many balls in the red ball? Red balls available in the R? 7 available. So 7 out of 12. So what we have to do? Just multiply, because this is only one thing. This is entirely one thing. This is one operation. This is second operation. Second choice. This is first choice. This is second choice. We should multiply these values together because it is a complete work. Not only drawing B1 is a work. B1 and also in the second attempt you have to draw red ball. That is a work. So what you do is required probability E. P of E is equal to P of B1 into P of R2 by B1 plus. Why plus? Because or there is another chance. What is the another chance? You can draw red ball at first and second ball is also red ball. Okay, understood? Now calculate these values. So this is equal to P of B1 is 5 by 10 into 5 out of 12 plus this is 5 by 10 into 7 out of 12. 25 plus 35, how much? 25 plus 35, 60. 60 out of 120, how much? 1 by 2. 1 by 2 is the answer of this question. Copy? Understood this question? Next copy 25. So there are three events with probabilities. What is probability of A? 2 by 5. Calculate A dash or A bar, whatever it is, will be same. So how much is this? 3 out of 5. What is P of B? 1 by 3. Implies P of B dash is 2 by 3, or you can also call it P of B bar. Both are same. What is P of C? 1 by 2 implies P of C dash is also 1 by 2. This is also called P of C bar. Okay. Given that P of A intersection C is equal to 1 by 5. P of B intersection C is 1 by 4. Then find the value of P of, what is this value? C by B. C by B is equal to how much? Can you tell me what is the formula of this C by B? C intersection B, B intersection C. Both are same. Yes, correct. By P of. Yes, P intersection C is how much? 1 by 4 by 1 by 3. Okay, P of B is look at here 1 by 3. So it will be how much? 3 out of 4. This is the first question answer. And next question. Second question is P of A dash union C dash. Is it union or what? Intersection. Intersection. Make it intersection. Make it intersection. So you can write P of A dash intersection B dash. A dash intersection B dash means you can write A union B whole bar. If you calculate this part, A's complement is A dash, union complement is intersection. Sorry, it is C. C complement is C dash. So this is equal to 1 minus P of A union C. Okay. That is equal to 1 minus, what is P of A union C? P of A plus P of C minus P of C intersection A. Okay, this is the addition rule. 1 minus, what is P of A? P of A is 2 by 5. 2 by 5. P of C is 1 by 2. 2 by 5. 1 by 2 minus, how much is this? A intersection C, 1 by 5. C intersection A intersection C, 1 by 5. Now do calculation. 1 minus of overall LCM is 10. This is 4 plus 5 minus 2. This is how much? 9 minus 2, 7. 1 minus 7 out of 10. This is how much? 3 out of 10. This is the answer. Okay, copy it. 3 marks questions. Next, copy 26. A bag contains 15 red marbles and 3 black marbles. 3 marbles are drawn one by one without replacement. What is the probability that at least one of the 3 marbles drawn be black if the first marble is red? How many marbles has to drawn? So a bag contains how many marbles? 5 red, 3 black. Total 8 marbles. 3 marbles are drawn one by one without replacement. Without replacement. Okay. So what he said, what is the probability that at least one of the 3 marbles drawn, at least one of the 3 marbles drawn be black if the first marble is red? Let A be the event that the first marble is red. B be the event second marble is black. C be the event the second marble is red. The event that the second marble is red. D be the event that the third marble is black. E be the event the third marble is red. So required probabilities are E be the required probabilities P of A, that means first marble is red and second marble is black, third marble is red, and the fourth marble is third marble is black and third marble is red. Okay. So these are the respective probabilities. Calculate it. Tell me the answer is correct or correct. A bag contains, draw the bag. A bag contains 5 red marbles, 3 black marbles. How many marbles has to select? 3. 3 marbles has to select. One by one without replacement. Without replacement. Without replacement, one by one. Okay. What is the probability that at least one of the 3 marbles drawn be black if the first marble is red? So what he said, what after if, that should be written in the denominator. First marble is red. First red. The same thing should be copied here. First red and at least one black. That's what he is asking. At least one black. Write down like this. First red marble, the same thing should be copied because it's a conditional question. Okay. What is given that after? What is known that after? What is after if, that should be written in the denominator. Remember, conditional questions. How do you identify conditional questions? You can find some words in the question. What are the words? Given that, known that, assumed to, noted to, if. If these words present in the question and the scenario will be looking like one thing will be well known, that kind of scenarios are called conditional questions. This is also conditional questions. How can you say it is conditional questions? He said, if the first marble is red in the last sentence. That means you have to assume that first ball must be red marble. So that's why the conditional question. So that should be written in the denominator. First red will be written in the denominator. And in the numerator, you have to copy the same thing in the denominator. First red. After that, make end. And after that, write down what to calculate the probability. The probability will be calculated for at least one black. At least one black. Okay. So what is first red? First will be red. 3 marbles are drawn without replacement. The first will be red. Come on, fix it. Draw first red ball. Come on, do this. 5C1 by, come on, 5C1 by 8C1. Am I right? Into what? It is without replacement. That means you are dropping somewhere else. You are throwing that marble somewhere else. You are not get back to the bag. Get it back to the bag. You are throwing somewhere else. So what you do is, how many remaining balls in the bag? You thrown away this first marble. How many red balls is there? How many red balls is there? Maybe the second red. Yes. What are the choices you can have after this attempt? You can have red plus Tell me the all choices. You are having red. Tell me also the remaining parts. Can I do it here? Yes, always first will be red. Red plus always first red black, or first red, or first black. These are the choices we are having. Am I right? Yes or no? Okay. And what about the numerator? Numerator is always first red and second at least one black. First red, at least one black means black, red. Okay. Or red, black. Look at this, one black. First always red, at least one black. The choices will be like this. Okay. And two black. Two black means RBB. Black. Understood? This is the probabilities we have to perform. Okay, now I am doing. Tell me denominators will be same. I am not mentioning the denominators, sample choices. Okay. Let's calculate first red. First I am doing RRR, triple R. So what is first R? So how many balls in the bag?
3 balls. 5 balls.
5 red marbles. So 5 red marbles. Yeah, let's calculate this. P is equal to, what are the choices? RRR, first R, red black, first R, black red, first R, black. And the numerator will be first R, red black, first R, black red, first R, black. So what is the first case, RRR case? First, how many marbles is there? 5. Next will be 4 into 3. Okay, first R, next R, sorry, first R 5, next R 4, next 3. Next 3 for what? Black marble. Okay, plus first R 5, next black is 3, and next R is 4, plus what is next R? 5, black, 3 into 2. What is the numerator will be? Numerator will be the remaining part. Remaining part is 5 into 4 into 3 plus 5 into 3 into 4 plus 5 into 3 into 2. So calculate this value how much? 5, 4, 3 how much? 5 4s are 20, 23s are 60, 22s are 62s are how much? 60, 120, 120, 30. 120, 30 is 150 divided by 150 plus one more 543. One more 543, 150 plus 60, 210. So 0 cancel. 3 table you can cancel 5 times, 7 times. So 5 out of 7 is the correct answer for this question. Next 27. So two dice are rolled. Two dice are tossed. Find whether the following two events A and B are independent. Two dice are tossed. Find whether the following events A, B are independent or not. How do you check that independent or not? If P of A intersection B is P of A into P of B, okay, then you can confirm that A comma B are independent events. Understood? What? This question, some questions 150 by 336. Is it 336 the sum? Check one more time that the denominator sum will be how much? Yeah, do it. 543, 543, 543. 3 times 360 is 180. 180 plus how much is this? 532. 1030. 180 plus 32, 10 only. Check this. Right? This is correct answer. Okay. It's sometimes it is making. Next, two dice are tossed. Find whether the following two events A and B are independent. Capital A, x comma y, x plus y is equal to 11. B is equal to x comma y, x is not 5, where xy denote the typical sample point. So what he said about A, x plus y should be 11. Okay. And what is, so you can take 5 comma 6, 6 comma 5. And B is equal to x comma y, x should not be 5. Should not be 5 means two dice are rolling, two dice are tossing. Okay. So B will be, x should not be 5. X should not be 5 means the first element, because xy it is ordered pair. Look at this xy. Xy is a ordered pair. X cannot be 5. So you can take all other values like 1, 2, 3, 4, 5, 6. Yes, y value you can take 5, no problem. So how many events are totally? And calculate A intersection B also. 6, 5 is the only value. Okay, intersection. So P of A will be 2 events out of 36. P of B will be 30 events out of 36. A intersection B will be only 1, 3, 6 comma 5, 1 out of 36. So what is asking for? We have to cross check independent or not. A intersection B is how much? 1 by 36. We will calculate, consider P of A into P of B. P of A is how much? 2 by 36. P of B is how much? 30 out of 36. This will be how much? 5 out of 108, and it will be cancelled, and 1 by 36. So finally, how much is it? 1 by 36. P of A intersection B is equal to P of A into P of B. So you can confirm that A comma B are independent events. He said not independent event. It should be independent. Maybe 5 by 108 is how much? It could not be 1 by 36, not 1 by 36. It is not equal. So cannot be independent. Yes, correct. Cannot be independent. Next question. Copy this question. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. The probability accidents are 0.01. By whom? Scooters. And 0.03. By whom? Car drivers. And 0.15 for truck drivers. Okay, respectively. One of the insured person meets with an accident. What is the probability that he is a scooter driver? Okay. So scooter driver E is equal to E1 is equal to insurance person scooter driver. E2 is car driver. E3 is truck driver. So E1, E2, E3 are mutually exclusive exhaustive events. Okay. So what we do, we need to calculate the probability of individual ones. P of E1. So what is the probability? What is the chance of P of E1? Scooter driver out of total 12,000 drivers. 2,000 scooter drivers out of 12,000 drivers. Look at, calculate this value. Look at this number. Scooter drivers is 2,000. Total is how much? 4,000 plus 6,000, 10,000 plus 2,000, 12,000. Out of 12,000, 2,000 are scooter drivers, P of E2, car drivers. 4,000 out of 12,000, 1 by 3, this is 1 by 6, and P of E3 is van drivers, 6,000 out of 12,000. It will be 1 by 3. Okay. Let capital A be the event, insurance person meet an accident. Capital A indicates the insurance person meet the accident. So he is a scooter driver. So what is the chance for that? It was given 0.01. The probabilities are mentioned given to you in the question. So 1 by 100. P of A by E2 is 3 by 100. P of A by E3 is 15 by 100. So this is Bayes' theorem. So required probability is he has to meet the accident with a scooter. Okay. So the probability according to Bayes' theorem, what is going on, that will be indicated as a denominator. What is required, that will be indicated as in the numerator. So calculate this part. So copy this question. This question okay, x plus y and this part. Very easiest question, but look by looks it will be looking like very tough, but it is very easy. Write down the probabilities. E1 is equal to scooter driver. So P of E1 is equal to 2000 by how much? 12,000. How much is this? 1 by 6. E2 is equal to what? No, what is E2? Car driver. What is P of E2? 4,000 by 12,000. That is equal to 1 by 3. What is E3? Van driver. P of E3 is 6,000 divided by 12,000, 1 by 2. So A is getting accident, A be the event, meet accident, meet accident. Okay, meets accident, meets accident by scooter. He's a scooter and meets accident. What is scooter accident chance? 0.01 he mentioned in the question. Look at this, 0.01, 0.03, 0.15. 0.01, that means 1 by 100. P of E2, A by E2, 0.03. So 3 out of 100. Probability A of E3, 0.15. 15 out of 100. So required probability P is equal to. So the total things happen in the denominator. So scooter driver chance is 1 by 6 and his getting accident is 1 out of 100. And car driver chance is 1 by 3 and his meeting accident will be 3 by 100. And van driver chance is 1 by 2 and his getting accident will be 15 by 100. And numerator will be scooter driver. So 1 by 6 into 1 by 100. Overall, you can cancel 100, this 100 overall in the denominator, from the denominators. 100 you can cancel. And don't cancel anything. 1 by 6 divided by, what left? Just write down 1 by 6 plus 3 by 3 plus 15 out of 2. So in the denominators also, the LCM will be 6. This is 1 plus. This is 2 3s are 6 plus. And 3 15s are 45. So now 6 6 got cancelled. So 1 out of 45 plus 6 is how much? 51, 51, 52. So 1 by 52 is the answer of this question. Okay. Next 29. An arm contains 3 red and 3 black balls. 3 red and 3 black balls. A ball is drawn. A ball is drawn at random. Its color is noted and returned to the arm. Okay. So a arm is there. What is the composition in the arm? 3 red and 5 black. 3 red and 5 black. Okay, one ball is selected from the arm and its color is noted and returned to the arm. What is the color? We don't know. Okay, this is first attempt. Moreover, 2 additional balls of the same color noted to put it in the arm. 2 balls are drawn at random without replacement from the arm. Find the probability both balls drawn are red colors. This is the same question. I send this document to you. Try this question. Okay, we are already done this kind of model question. Next, 30th question. Bag 1 contains 5 red and 5 black balls, and bag 2 contains 3 red and 4 black balls. One ball is transferred from bag 1 to bag 2, and then 2 balls are drawn at random without replacement from bag 2. The balls so drawn are both found to be black. Find the probability that the transferred ball is black. Okay. So copy this question. It's very interesting question. Try this kind of questions. These are very important questions. So write down bag 1 contains. You have to draw the diagrams in the examination also. Bag 1 and bag 2. So bag 1 contains 4 red, 5 black. Bag 2 contains 3 red, 4 black. One ball is transferred from bag 1 to bag 2. One ball. One ball is transferred from bag 1 to bag 2. And then 2 balls are drawn at random without replacement from bag 2. 2 balls are selected. 2 balls are selected or drawn at random without replacement from bag 2. The balls so drawn are both found to be black, and this is black. Find the probability transferred ball is black. Transferred ball is also black. Okay. This is also Bayes theorem. So first we will draw that first transfer ball is black ball. What is the chance of drawing black ball from this one? 5 out of 9. Or from the first, you can draw the red ball also. There is a choice. What is the red ball choice? 4 out of 9. And second draw, what is the choice for the second draw? The second draw will always produce 2 black balls, right? So second draw will be black balls, 2 black balls. It was fixed. 2 black balls means how many black balls is there? 4. So you have to draw 4C2 out of 7C2. Okay. And also you can draw also if red ball is transferred, 1 ball is transferred, no? So total balls are 8. Make it 8. This will be 8. Remember this. 8C2. Black ball is transferred. So 1 ball is moved. So look at this case. Black ball is transferred. 5 out of 9. And in this case, from the second, what is the composition now? New composition. Actually, before transformation, Of the ball, there are 7. And 1 black ball is transferred. So total 8 and black balls are 5. So total 8, 2 balls has to draw. Black are 5. So 5C2 by 8C2. This is correct answer. And red ball is transferred. In this case also, we have to draw black balls from the second situation. Second situation, again 8C2 situations, but numerator will be 4C2 only. Okay, the first drawn here, black balls are 4 available because you are transferring in this situation red ball. Okay, understood? Now, what we do is required probability, let it be A, let it be A. So our probability P is equal to, just multiply these values together and add it. So P of B1 into P of B2 plus P of R1 into P of B2. Always the second choice will be produced 2 black balls. What we required? We required first will be black ball is transferred. That is required. Black ball, and then after a black ball, the second is also black ball. Second draw will also black. So this is the probability you have to perform. What is P of B1? 5 by 9 into B2 is 5C2 by 8C2. 5C2 how much? 5C2 10. 8C2 how much? 8 into 7 by 2, 28. Plus R1. R1 is how much? 4 out of 9. Into P of B2 is how much? In this case B2. 4C2 is 6. 8C2 is 28. And in the numerator, write down 5 out of 9 into 10 out of 28. This is the same case. Both cases are same cases. You can write the same numbers. You can cancel 9 and 28 together because each and every fraction you are having the same. 5 tens are 50 out of 50 plus 24. How much is this? 50 out of 74. You can cancel it if possible. 25 out of 37. So this is the answer. 25 out of 37. Hmm? Yes. Hmm? Hmm? So 12 5 only. We'll finish only 10 questions is there.
Questions.
Hmm.
So much. Last
Why you are not copying anything?
copy.
Hmm. You are not learning anything. That means you know that result will be how much? No. So there are 3 arms containing 2 white and 3 black balls, 3 white, 2 black balls, and 4 white and 1 black ball respectively. There is an equal probability of each arm being chosen. A ball is drawn at random from the chosen arm and it is found to be white. Find the probability that the ball drawn was from the second arm. Okay. So how many arms is there? 3 arms. Write down arm 1. Draw the diagrams also. Okay. Second arm, third arm. The first arm will contain white 2 and black 3. Second arm will contain white 3, black 2. Third arm will contain 4 white and 1 black. 1 black. Okay, this is the composition of the arms. The equal probability for getting these arms should be selected. That's what he says. Equal probability for each arm being selected. A ball is drawn at random from the chosen arm. Okay, one arm is chosen, and from the arm found to be white, find the probability it is from second arm. Okay, so let us draw one by one. Okay, so he said what is the first arm chosen probability? 1 by 3. And second arm chosen probability will be P of 2. It is also 1 by 3. third on chosen probability will be also 1 by 3. Okay, right now like this. Okay. So after that, if you choose this R and draw white ball from that after choosing this R. So P of I by W by I. That means white ball you are selecting from this R. 2 out of 5. Am I right? 2 out of 5 because total balls available here is 5 balls out of 2. Okay. So if you select second arm and you are selecting white ball from that, white ball from the second arm, white ball from the second arm. Look at the white ball, 3 out of 5 again, same chance. And the white ball from the third arm, white ball, so 4 out of 5. Okay. Now required probability, the Bayes theorem is very easy. So required probability P is equal to what is happening, the total should be mentioned here. So selecting first arm, after selecting first arm, drawing white ball from there. Plus selecting second arm, the whole thing you should mention in the denominator. Okay. After selecting second arm, you have to draw white ball from that. Plus selecting third arm, after selecting third arm, you have to get a white ball from that. What we required? We required second arm is selected and the selected arm will provide a white ball. That is what we require. That will be in the numerator. That is simple Bayes theorem. Okay, understood. What we required in the numerator, what is going on, what is happening in the entire process, that is in the denominator. The denominator is sometimes it is called total probability also. Okay. So his wishes will be unique. He's asking separately. It will be from second on. It will be from third on. Then you can understand that it is Bayes theorem, Bayes problem. Okay, so the chance for selecting a second on is 1 by 3. Getting white ball from second on is 3 by 5. So 1 by 3 into 3 by 5 in the numerator. 1 by 3 into 2 by 5 from the first on. 1 by 3 second on selection and drawing white ball from second on is 3 by 5. 1 by 3 selecting third on and drawing white ball from the third on, 4 out of 5. So overall, you can cancel 1 by 3 by taking common or somewhere else. You can cancel this 1 by 3. And 5 is also got cancelled as a denominator, overall denominator. So what left in the numerator? 3. What left in the denominator? 2 plus 3 plus 4. How much is it? How much is it? 3 out of 5 plus 9. Okay. 5 plus 4, 9. So 1 by 3 is the answer. 1 by 3 is the answer. Understood? Look at this one. Right? Next question. Two dice are thrown simultaneously. If x denotes the number of sixes, find the expectation of the mean. So this is very simple question. We already solved this kind of questions in 2 marks questions. You can solve it. So two dice are thrown means how many total sample space? 36. Okay. Like 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 3, 1, and so on. 6, 6, totally 36 events you are having. So what he said, if x denotes the number of sixes, that means 0, 6, 1, 6, 2, 6. These are the possibilities, okay, on that. Probability of getting a 6 in a single throw is 1 by 6. Not getting 6 is 5 by 6. So always you have to calculate in a single throw. In a single throw, calculate the probability. This is what called P and this is what called Q. These PQs are considered in a single throws. Okay, P is 1 by 6, that means getting 6 or not getting 6, 5 out of 6. Then 5 out of 6 means what? Getting 1, getting 2, getting 3, getting 4, getting 5. These are 5 choices of not getting a 6. Getting 6 is only 1, so 1 out of 6. So create a table. So how many tosses are done? 2 tosses. 2 tosses means 0, 6. 0, 6 means what is the probability? First toss not getting 6, second toss not getting 6. 5 by 6, 5 by 6, 20 out of 36. Write down here. And similarly create 1, 6. So 1 by 6 into 5 by 6 or 1 by 6 into 5 by 6, 10 out of 36. And next, both getting 6s, okay, 1 out of 36. This is the expectation. Expectation means you should multiply with the x values and p of x values. So 0 into 25 by 36 plus 1 into what? 10 out of 36, 2 into 1 out of 36. It will be how much? 1 by 3. Okay, done. Next 33. A man is known to speak truth 3 out of 5 times. So what is the person? You can say E1. Okay, copy this question. I will show you this solution. A man is known to speak 3 out of 5 times. Let us suppose the person is A and he will speak truth is A. Truth, first person. So P of A is equal to 3 out of 5 times. 3 out of 5 times. That automatically P of A bar is how much? 2 by 5. That means 2 times he will lie. Okay. Next, he throws a die and reports that it is 4. So what is the probability of getting 4? Getting 4 is B. Let us suppose B. It is chance is 1 by 6. Not getting B4 is 5 out of 6. The probability that is actually 4 is the probability that it is actually 4 is. Copy this. So look at this. P of 1 by 6 and 5 by 6, true and false probabilities. Actually, man speaks truth is 3 by 5, and probability that man does not speak truth is 2 by 5. Okay. So after that, calculate that 1 by 6 into 3 by 5. That means what? 1 by 6 is truth and 3 by 5 is, what is 3 by 5? What is 3 by 5? Man reports 4 occurs. Man reports 4 occurs is A. The probability man speaks truth is 3 by 5. How did I get this? 3 out of 5 times. Truth chance. This is getting for not getting for. Okay. So this E1 is showing 4 and he's true. 5 by 6 means not showing 4. He's telling 2 by 5 means he's false and the false. And what he said, it is showing die show is 4 and he's telling truth. Okay, calculate this probability. Find the probability, it is actually 4. So required probability P is equal to, so what he needs actually 4. Actually 4 means 1 by 6 into what he reports that it is 4. That means he is telling truth. Truth probability is 3 by 5. Truth probability is 3 by 5 and actually happen. Look at this. He throws a die and reports that it is 4. That means he telling correct. Actually that it is 4 means actually happening things is also 4. So the same thing you should copy in the denominator. 1 by 6 into 3 by 5 plus write down reverse order 5 by 6 into 2 by 5. Okay, so calculate this part. You can cancel these values 6 and 5 together. Okay, so numerator will be 3, denominator will be 3 plus 5 2s are 10. How much is this? 3 out of 13. Copy it. Understood? Next question. This is very simple question. 34. A factory has 3 machines X, Y, Z producing 1000, 2000, 3000 bolts per day. The machine X produces 1% defective balls, 1% defective balls, bolts, Y produce 1.5% defective and Z produce 2% defective balls. At the end of a day, a bolt is drawn at random, it is found to be defective. What is the probability that is defective bolts have been produced by the machine X? Very direct question, no other substitutions. Copy this question and direct write down the answer. Look at this. So E1, E2, E3 events of X, Y, Z produces bolts per day. How many bolts they are per day producing? 1000 out of how much? 2000, 3000, 1000, 6000. Okay. So 1 by 6 probability. That means machine A produce chance is 1 by 6. Machine B similarly 1 by 3. Machine Z is 1 by 2. So what is the chance for defective bolt? 0.01, 0.015, 0.02. Now we required a defective bulb produced by A. So that is P of E1 into P of A by E1. Okay, can I write separately? Hmm? Understood this question? Next. A laboratory blood test is 99% effective in defective a certain disease. When it is in fact present, however, the test is also yields a false positive for 0.5% of the healthy person tested. That is, if a healthy person is tested, then with the probability 0.005, the test will imply he has a disease. 0.1% of the population actually has the disease. What is the probability that a person has a disease given that at least his test is positive result? Very interesting question. Right now, laboratory blood test is 99% effective in detecting the certain disease. What is the laboratory chance? 99%. That means 1% chance the laboratory report is false. Okay. A certain disease, for example, take corona. Okay. Corona. When it is in fact the present, okay, that is going on present. However, the test is also yields a false positive for 0.5%. Okay. For a healthy person tested. If he is a healthy person, he tested, the false report will be chance for getting false report is 0.5% with a probability 0.005. The test will imply he has a disease. 0.1% the population actually has the disease. Actually, what is the percentile the population has the disease? 0.1%. If a healthy person, that means he is not having any disease. If he tested, the test will fail 0.5%. Okay, what is the pass percentage? 99%. Good reports. So what is the probability the person has the disease? That means he is a diseased person, given that the result is positive. So result is positive means what? For which purpose we are testing? Positive or negative? Positive means he has the disease. Negative means he is not having that disease. That is the result test, right? So it should be positive result means he has the disease and he is a diseased person. Okay. So look at the scenario of solving. Let us suppose E1, E2 be events that a person has disease and a person has not disease. What is the person has disease? 0.1%. 0.1% means 0.1 by 100. That means 0.1000. Just wait. After this question, I will. No? P of E2 is 1 minus 0.1%. That means 99.9% he is not having the disease. This is disease probability, not having disease probability. Okay. Suppose A is the event that the test is positive. What is the chance for test is positive? 99%. Test is failed. False test is 0.5%, he said. So 0.5 by 5 by 1000 by Bayes theorem. Look at this. Total happening things. What are the happening things totally? P of E1. P of E1 means he is a disease. He has the disease. Test is negative. He has he's not having the disease. Test positive is asking, no? A by E1. Test is positive. Positive test means A by E1 only required. 99 only you should use. and test is negative 5 by 1000. Just multiply both of these values. So 1 by 1000 is healthy person, 1 by 1000, and test is positive 99%. Test is correct. And P of E2 means he is not having disease and test fails. Test fails means negative test is required. So numerator will be what we required. What we required means he is a diseased person, 1 out of 1000, and test is showing the same thing. Test is showing the same thing means test reports are positive, 99% positive. That means correct report. So this is calculate this part when you will get finally 22 out of 133. Okay. Look at the remaining problems 36 and 37, 38, 39, and 40. Do practice of these questions out of up to 40 questions and check the remaining 5 marks questions also. It is same as the 3 marks questions. Okay. That's the end of this probability chapter. And in the next class, we will discuss the remaining concepts. Okay. That's all for today. Bye bye.